Summary section 14.4. Let's consider a function of two variables at a point A and B. If the tangential plane exists, if it exists, the tangential plane at A and B will look like this. F sub x at the point AB times x minus A plus f sub y at point A and B times y minus b. So x minus the x value plus minus z minus f of A and B. Remember, this f of A and B is the z value that comes with A and B if I plug it into here. So this is the z value of the point A and B, of the point on the graph of function f of x and y that correspond to point A and B in the domain. Therefore, rewriting it, this is a point on the graph of the function, and that's the tangent plane on the that is anchored on that point. Now, my question is, this z over here is approximating points, the f value for points near A and B. This difference, z minus f of A and B, is dz, which is approximating delta z. That is, for points near A and B, the z value that we're expecting from this function is approximated by this z, and this is the approximation of the difference of that z value. This is the actual difference between the z value. Here is the delta y, here is delta x. Now I can do total differentials. So this was tangent plane. Then I want to do total differentials. And that is, if I take dz to the other side, dz is going to be equal to f sub x A and B times delta x plus f sub y A and B times delta y. Now, the last thing is that I'm talking about approximation using z. That approximation using z is actually called linearization. That's the approximation using linear method. And linear approximation, I have to solve for that z. Solving for that z, I distribute that negative sign, and I get z comes out as a positive to the other side, and I will get f sub x at A and B times x minus A plus f sub y at A and B times y minus b, and plus that f of A and B. This is the linear approximation. This z gives me the linear approximation. The other name for that is going to be L at A and B of x and y. So linear approximation of f at point A and B for any x and y value near A and B. So this is how one of them implies the other one.